This is part 1 of our lesson on solving trigonometric equations by factoring. You will notice that the practice questions for today are at the top of the page. That is simply because I needed more space on the second page for our second example. So the first question that we are going to do says solve each of the following without using a calculator where 0 is less than or equal to x is less than or equal to 2 pi. So it is asking us to solve. So we want to find the value of x. We are not using a calculator, so we will be using our yellow sheet. And the values of x should be somewhere between 0 and 2 pi, and that just means one full cycle of the graph, or the 4 quadrants if we do the xy axis. So our first example here says sine x plus the square root of 3 times sine x times tan x equals 0. So all of the questions today are going to involve factoring. And when I factor, I want there to be at least a ratio that's the same in each of the terms. So if I don't have the same ratio in each term, I would try to use an identity. But looking at this question, I do see that there is a sine x in the first part, and there's a sine x in the second part. So I am going to try to factor this. We could use variable replacement, but because I see that they both have a sine x, I think I'm going to try to common factor. So I'm going to common factor out sine x. And when I do that, I'm going to be left with sine x divided by sine x is 1. The square root of 3 divided by sine x, still the square root of 3. The sine x divided by sine x cancels out, and then I still have tan x. So I have sine x times 1 plus the square root of 3 tan x, and that equals 0. I think I might just zoom in a little. There we go. So from here, it is now factored. I have sine x times 1 plus the square root of 3 tan x. So since it is factored and it equals 0, I should be able to take each factored part, set it equal to 0, and solve. So I'm going to start with sine x. I'm going to let sine x equal 0. And then I'm going to do the same thing with the 1 plus root 3 tan x. I'm going to try to bring it a little over to the side to create some space for myself. So maybe over here. So I have 1 plus the square root of 3 times tan x also equals 0. So let's start with sine x equals 0. In order to solve for x, I need to do the inverse operation of a sine, and the inverse of a sine would be the inverse sine. So I'm going to do that x equals the inverse sine of 0. Now, if I were using a calculator, I would make sure that it was in radians, and I would just calculate the inverse sine of 0. But we're not allowed to use a calculator. That doesn't mean I can't do it. It just means that I will have to use the skills on my yellow sheet to help me figure out how to do this. So the first thing I do is I always look at the graph. And I don't have my yellow sheet with me today, so you are going to have to look at yours, and then I might draw the graph on the page. I would look to see, is there somewhere on the graph where the y value is 0? So I am just going to draw a quick little diagram of what a sine graph looks like. So we're looking to see, are there any points where the y value is 0? And there are. It is 0 here, here, and here. So these are the points 0, pi, and 2 pi. So there are 3 different places where the graph has a y value of 0. That would be at x equals 0, at x equals pi, and at x equals 2 pi. All right, so we already have 3 solutions, but we haven't even looked at the second bracket yet, which is the next thing that we are going to do. So I have 1 plus the square root of 3 tan x equals 0. So we are going to rearrange to isolate for tan x. So I would start by subtracting 1 from both sides to get the square root of 3 times tan x equals, and then 0 take away 1 is negative 1. And then from there, I would try to move the square root of 3 to the other side by dividing both sides by the square root of 3. So I would get that tan x equals negative 1 divided by the square root of 3. And then the last thing I need to do to isolate for x is do the inverse tan of negative 1 over the square root of 3. Now, I didn't mention it, but I'm hoping you noticed that negative 1 divided by the square root of 3 is not something that I can do in my head without a calculator. So that's why I didn't work that out. So from here, I would try to think about the graph. And is this a number that I can read off of a tan graph? And the answer is no. The only y values that I can read off of a tan graph would be 0 or infinity or undefined. So this is neither 0 nor infinity. So I know that I'm going to have to do something else. So then the next thing I would do is I would look to see, is there a special triangle that has sides of 1 and the square root of 3? So looking at tan, the ratio for tan is opposite over adjacent. So I am looking for a right triangle, one of my special triangles, that has potentially an opposite side of 1 and an adjacent side of the square root of 3. So I only have one triangle that has a side of 1 and root 3, and that is this triangle here. I believe I am drawing it backwards from what is on your sheet, but that's okay. So I've got pi over 3 as one of the angles, pi over 6 as one of the angles, and then the hypotenuse is 2, this side is root 3, and this side is 1. So I think on yours it might be flipped over. No, actually it might look just like that. So looking at my triangle, this does have a side of root 3, and this does have a side of 1. So this is the opposite, so I'm going to label that this is the opposite. This is the adjacent, so I'm going to label that this is the adjacent. So is there a triangle that has an opposite of 1 and an adjacent of 3? Yes. This side over here would be my hypotenuse. It's not the one that was given in the question, but it is still the hypotenuse. And from here, what I would do is try to figure out which angle was used to label this triangle. So I like to look at what is opposite the opposite. So the one across from the opposite side should be the angle that I use to label my triangle, which means the angle that we used to label this triangle was pi over 6. That doesn't mean my answer is pi over 6. It just means the angle that we used in doing our calculations was pi over 6. The other thing that I need to think about is the negative. So I do see that this is the inverse tan of negative 1 over root 3. So I'm going to think about what that negative tells me. The negative will help me locate which quadrant my angle came from. So I'm going to just draw that a little bit up here. I'm going to draw my xy axis, and I'm going to use my cast rule. So we always start at 0. Full circle is 2 pi. Halfway is just pi. I don't usually label, but the top one is pi over 2, and the bottom one is 3 pi over 2. So my cast rule starts in quadrant number 4 and goes C, A, S, T, and the cast rule tells me which ratio is positive in which quadrant. I know that my tan is negative. It is negative 1 over root 3. So I want to think about, where is tan negative? Is tan negative in quadrant number 1? Nope, they're all positive in quadrant number 1. Is tan negative in quadrant number 2? Sine is positive in quadrant 2, which means tan is negative. So this, the terminal arm, my angle, could be in quadrant number 2. Could my angle be in quadrant 3? Nope, this is T, tan is positive in quadrant number 3. Could my angle be in quadrant number 4? Yes, it could. Cosine is positive, so tan is negative, which means there are 2 possible angles here. Option number 1 would start at 0, like all angles do, and end here in quadrant number 2. That would be one possibility. My second possibility is the one that starts at 0 and goes all the way around to quadrant number 4. So this big angle here is my second option. Now, where does the pi over 6 come into this? The pi over 6 is the little angle that my terminal arm makes with the closest x-axis. So on this one, that pi over 6 would be there. On this one, the pi over 6 would be here. This is the closest to the x-axis. This is the closest to the x-axis. So then from here, I need to figure out if this little tiny bit is pi over 6, what is this larger angle? And if this little bit is pi over 6, what is this larger angle? So I like to identify what quadrant the angle is coming from. So I usually write that this is quadrant 2. So I would write Q2. And this one is in quadrant number 4. So I have one from Q4. What we're going to do is think about our angle here. So this angle, the closest marking I have is pi. But this angle is a little bit smaller than pi. Pi would be a straight line. This is a little bit smaller than a straight line. How much smaller than a straight line? Pi over 6 radians smaller. So this would be pi, my straight line, and then minus that little bit of pi over 6. So the angle in quadrant 2, x, is going to be pi minus pi over 6. And then the angle in quadrant 4, this one here, the angle is going all the way around, almost in a full circle, except it's pi over 6 less than a full circle. So the closest x-axis measurement to this angle is 2 pi, and then it's a little bit smaller than 2 pi. So I would do 2 pi minus pi over 6. All right, from here you can calculate by getting a common denominator. So pi would be the same thing as 6 pi over 6 minus pi over 6, which would give me 5 pi over 6. The one in quadrant 4 is 2 pi minus pi over 6. If I get a common denominator, this one is 12 pi over 6 minus pi over 6, which gives me 11 pi over 6. Right. So I have two angles that came from the tan part, and I have the 3 original angles that came from the sine part. So I now have a grand total, I'm going to zoom out, of 5 different angles here. X could be 0, it could be pi, it could be 2 pi, it could be 5 pi over 6, or 11 pi over 6. Okay, well, I will see you in the next video to take a look at example B.